Okay, so good morning everyone. In the last lecture, we talked about deadlock avoidance, where we learned how to deal with deadlocks in the case of resources with single instances, as well as if we have resources with more than one instance. And in the case of resources with single instances, we have to use resource allocation graph, and we can avoid the deadlock. We will not grant the resource if there is a cycle formation. And in the case of resources having multiple instances, we talked about Banker's algorithm, where we see how we have to calculate the need of each and every process, and according to the availability, we will find some order which is known as safe sequence. And if we are able to find safe sequence, then definitely the system is in safe state and there isn't any possibility of deadlock. But if we do not have any safe sequence, then the system will be in unsafe state and deadlock will be there. So today we have to cover the last topic of this chapter number 7, which is deadlock. So deadlock detection and deadlock recovery. And initially we started with, there are 4 different ways to handle the deadlock. So we talked about deadlock prevention, then deadlock avoidance. Now today we will focus on deadlock detection and deadlock recovery. So if in our system we do not have either a deadlock prevention or deadlock avoidance algorithm, then definitely deadlock situation may occur. So in this particular situation, the system may provide either any deadlock detection algorithm as well as an algorithm to recover from the deadlock. तो अगर हम deadlock prevention या deadlock avoidance algorithm लगा रहे हैं, then definitely we can prevent or we can avoid deadlock in our system. But if we are not using either deadlock prevention or deadlock avoidance algorithm, then definitely there's a huge possibility that deadlock may occur in our system. So in that particular case, the system must provide an algorithm which will detect that deadlock occurs in the system, and along with the detection, the system must provide an algorithm for the recovery from the deadlock. So here again we have 2 different cases. First of all, we will talk about the system where we are having only single instance of each resource type, and later on we will talk about the case where some of the resources might have more than one instances. So in the case of deadlock avoidance, we used to have a resource allocation graph, but here in the case of deadlock detection, we will be having another graph which is a variant of resource allocation graph, which is known as wait for graph. So now here, instead of resource allocation graph, in deadlock detection we will use wait for graph, and in this wait for graph we are having only one type of nodes which are only processes. In the case of resource allocation graph, we are having 2 different type of nodes. One node is for processes which are represented in circle, another node was for the resources which was represented using rectangle. But if I talk about this wait for graph, so here we have only nodes in the form of processes, and if there is a node from process Pi to Pj, that means the process Pi is waiting for Pj process to release the resource which Pi requires. And this is how the overall scenario works. And this is resource allocation graph and its corresponding wait for graph. So here you can see a system has 5 different processes from P1 to P5, and we have 5 different resources from R1 to R5, and all resources have only single instance. There isn't any multiple instance of each every resource. So all R1, R2, R3, R4, R5 is having only one copy. And you can see प्रद्युम्न आप अपनी JUIT वाली email ID से लॉगिन करो. And this is the system, and you can see clearly here P1 is holding R2 and it is waiting for R1, P2 is holding R1 and it is waiting for R3, R2, R3, R4, R5 and so on. So this is resource allocation graph which we used in deadlock avoidance. But if we talk about deadlock detection, we have wait for graph. So this is wait for graph. तो ये wait for graph हमारा resource allocation graph से ही बनेगा. तो यहाँ पे आप देख सकते हैं कि जहां जहां भी P1 से R1 एंड R1 से P2 यहाँ पे edges थी, तो यहाँ पे हमने resources वाली nodes को remove किया है. We have directly connected those processes nodes which are there. So if there is a node from P1 to P2, that means corresponding resource allocation graph में edge होगी from P1 to R1 and R1 to P2. Similarly, you can see here R2, from P2 to P3, there is an edge through R4, so we have directly connected P2 to P3. Similarly, from P2 to P5, we have such kind of edge. So here we just remove all the resource nodes and we directly connect all the processes nodes. So this is how we get the wait for graph. And now just to detect the deadlock, the scenario will remain same. We will invoke an algorithm that will search for the cycle in the graph. So same scenario rahega which we used to have in deadlock avoidance. So here exists a cycle P1 to P2, P2 to P3, P3 to P4 and P4 to P1. So if our wait for graph contains cycle, then definitely there exists a deadlock, and if there is no cycle in the wait for graph, then deadlock is not there. So this is how we can detect the deadlock, and an algorithm for deadlock detection in the graph requires an order of n square operations, where n is the number of vertices in the graph. So this is the concept of complexity. You might be studying data algorithms and analysis subject, and you might know how to compute the complexity and how to calculate the things. So this is all about deadlock detection, where we have all the resources with only single instance, and this is how we can draw the wait for graph from the corresponding resource allocation graph. And now if we have resources with multiple instances, then we will definitely use the same concept as we have in the banker's algorithm. We will have some data structures like vector of length m. So here m is the number of resource type and n is the total number of processes in the system. So available will tell us the total number of available resources of each type. Allocation is a matrix of n cross m, which defines the number of resources of each type which are currently allocated to each process. Now instead of max, here we have another matrix with the name request. So यहाँ पे सिर्फ यही difference है bankers algorithm के data structure में and this algorithm data structure, that instead of max matrix we have a request matrix. So it is also a n cross n matrix, where n is the number of processes and m is the total number of resource type. And this request matrix indicates the current request of each process. So instead of maximum demand of each process like banker's algorithm, here we will having request matrix जो हमें क्या बताएगी कि इस process ने कितने resources की request की है currently, and allocation क्या बताएगा कि कितने हमें allocate हो चुके हैं. So this is the algorithm, so I'm not discussing it in detail, so just go through this example. So the same kind of example which we covered in this banker's algorithm. So we have same 5 processes P0 to P4, and we have 3 different resource type which are named as A, B and C. We have 7 instances of A, 2 instances of B, and 6 instances of resource type C. So you can see all 7, 2 and 6. If you will add this allocation column, so this is 7, this is 2, this is 6. So all 7 to 6 has been currently allocated. Therefore, we having available 0, 0, 0. And instead of max here, we have request here. So that means process P0 को currently 0, 1, 0 allocated है and it is requesting for 0, 0, 0. Process P1 को currently 2, 0, 0 already allocated है and it is requesting for 202. So this is what we have to understand from here. We do not need to calculate the need matrix. So we can see the same concept we have to apply here. We have to find the safe sequence if we are able to satisfy or if we are able to fulfill the request of each and every process in some order, then definitely we can detect or we can just have the information regarding the deadlock existence in the system. So here you can see process P0 as well as P2 do not request for any of the resources. Here it is 000 and here again it is 000. So easily, first of all, we can fulfill the request of process P0, and P0 requires 000 resources, so that means definitely P0 can execute its task first, and it is going to release the currently allocated resources. That means when P0 will finish its task, we will be having 010 available resources, and after that P2 also do not require anything, so that means we can easily allocate or P2 can easily execute its task, and it is going to release 303. That means after P2 will finish its task, we will be having 313 available resources, and in this particular order, P0, P2, then P3, then P1, then P4, definitely we will be able to fulfill the requests of all the processes which are currently requesting some of the resources. So this is the scenario. And now let's see one more case. If in the same scenario, if process P2 requests an additional instance of type C, तो अगर भाई process P2 000 की जगह 001 की रिक्वेस्ट करेगा, तब हमारे सिस्टम में क्या चेंजेस आएंगे? रेस्ट ईच एंड एवरीथिंग इज सेम, एलोकेशन भी सेम रहेगी, अवेलेबिलिटी भी सेम है. नाउ इंस्टेड ऑफ 000, process P2 is requesting for 001. That means one instance of resource type C is also required by process P2. So in this particular case, you can see the system will not having the safe sequence. You can just solve it also, and I'm just going to show you. So first of all, 000 process P0 will successfully execute, and it will going to release 010. So once P0 will be executed successfully, then we will be having available vectors as 010. So आप 010 को चेक करो, इन चारों में से किसी भी प्रोसेस के लिए आप 010 की रिक्वेस्ट को सेटिस्फाई नहीं कर पाओगे. हमारे पास अवेलेबल 010 होंगे. सो P1 को 2 की रिक्वायरमेंट है, हमारे पास 0 है. एंड P2 की बात करें तो हमारे पास यहाँ पे सिनेरियो चेंज हो गया. P2 नाउ रिक्वायर्स वन इंस्टेंस ऑफ C, बट वी आर हैविंग 010 अवेलेबल. दैट मीन्स हमारे पास अवेलेबल C के 0 इंस्टेंसेस हैं. सिमिलरली अगर P3 की बात करें, P3 रिक्वायर्स वन इंस्टेंस ऑफ A, बट अवेलेबल में क्या है अभी? 010. दैट मीन्स A के 0 अवेलेबल है. और प्रोसेस P4 की बात करें, सो P4 रिक्वायर्स 2 इंस्टेंसेस of resource type C, but we are having 010 in the available vector. So that means अगर हम यहाँ पर process P2 की जो request है उसको 001 कर दें, which is this, then सिर्फ P0 की ही request को हम fulfill कर पाएंगे. बाकी चारों processes की from P0 to from P1 to P4 we won't be able to satisfy the entire scenario. So this is the question which they have asked, that if we are going to increase the request of process P2 of resource type C by 1, then the system will be in the safe state or not. So you can see we can reclaim resources held by the process P0. सिर्फ P0 की ही request को हम fulfill कर पाएंगे और बाकी सारे processes की request को हम fulfill नहीं कर पाएंगे. So in that particular case, कौन-कौन से processes deadlock में होंगे? P1, P2, P3 and P4. These 4 processes will be in deadlock. Only P0 will be able to get all the resources because actually उसे कुछ चाहिए ही नहीं, उसके already जितनी उसे request demand है उसके पास already वो resources available है. So this is the concept of deadlock detection in the case of multiple instances of resources. So the major question is when and how oftenly we have to use this deadlock detection algorithm, and how many processes will be there which will be having the deadlock situation, and whether we have to restart them from the very initial phase or we can just continue them. So if the deadlock occurs frequently in the system, then the deadlock detection algorithm should also be invoked frequently. So the resources allocated to the deadlock processes will be idle until the deadlock can be broken. Also, the number of processes in the deadlock cycle may grow. So that is not a very good practice to apply deadlock detection algorithm each and every time. And there is a possibility that the deadlock processes number may also increase in such cases. So this is all about deadlock detection. Moving further to the last topic. So if the system is able to detect the deadlock through deadlock detection algorithm, then there should be some provision for deadlock recovery. तो deadlock अगर detect हो चुका है कि deadlock आ चुका है system में, देन हमारे पास कुछ प्रोसीजर होने चाहिए डेडलॉक को रिकवर करने के, कि बाकी हम फिर से हम सिस्टम को नॉर्मल स्टेट में लेके जा सके. सो मेनली देयर आर टू डिफरेंट मेथड्स फॉर डेडलॉक रिकवरी. वन इज नोन एज प्रोसेस टर्मिनेशन and second is known as resource preemption. So there are two different ways by which we can apply the concept of deadlock recovery. And in process termination also we have further two categories. Very first says that abort all the deadlock processes. तो जितने भी processes deadlock state में गए हैं सभी को terminate कर दो, सभी को abort कर दो. लेकिन इस मेथड से डेफिनेटली हमारा डेडलॉक साइकिल ब्रेक हो जाएगा, लेकिन बट एट ग्रेट एक्सपेंस. तो इसके लिए एक बहुत बड़ी we कह सकते हैं we will be having some cost, and the deadlock process may have computed for a long time, and the results of these partial computations must be discarded and probably we will have to be recomputed later. So it is not that much easy to abort all the deadlock processes at the same time. There will be a great expense by doing this thing. And second method of process termination is we can abort one process at a time. So we can just try to abort or terminate only one process at a time. Then we will check whether there is a deadlock cycle, or then we will apply the deadlock detection algorithm again. So this method is also not that much easy to implement, because पहले हम एक प्रोसेस को टर्मिनेट करेंगे, उसके बाद फिर से हम डेडलॉक डिटेक्शन एल्गोरिथम अप्लाई करेंगे, फिर चेक करेंगे, फिर अगर तब भी हमारे पास डेडलॉक है फिर नेक्स्ट प्रोसेस को हम अबॉर्ट या टर्मिनेट करके फिर से हम बार बार डेडलॉक डिटेक्शन एल्गोरिथम, या अगर हम रिसोर्स एलोकेशन या वेट फॉर ग्राफ की बात कर रहे हैं तो हम बार बार साइकिल चेक करते रहेंगे. सो बोथ ऑफ दीज टास्क आर नॉट दैट मच इजी टू इम्प्लीमेंट. एंड अगर हम वन बाय वन एक प्रोसेस को टर्मिनेट करेंगे, देन देयर आर सो मेनी डिफरेंट क्वेश्चंस कि कौन से ऑर्डर में हम प्रोसेसेस को चूज करें, कि जिस प्रोसेस की सबसे लोवेस्ट प्रायोरिटी है हम उसको पहले टर्मिनेट करें, या जिसके पास रिसोर्सेज कम हैं, या जो पहले प्रीएम्प्ट कर सकता है. सो देयर विल बी सो मेनी डिफरेंट क्वेश्चंस हाउ टू चूज that process, how to specify the order of the processes in which we will terminate or abort the processes. So the deadlock recovery overall is not an easy task, but this is one of the method by process termination. Either we can terminate all the deadlock processes at once, or we can terminate the processes one by one, and after each termination we will check फॉर द डेडलॉक डिटेक्शन की इस प्रोसेस को रिमूव करने के बाद क्या अभी भी डेडलॉक में है कुछ प्रोसेसेस, या डेडलॉक खत्म हो चुका है. तो अगर डेडलॉक खत्म हो गया दैट इज वेरी वेल एंड गुड, बट इफ वी still are in the deadlock state, then definitely we will again abort any one of the process. तो वो कौन सा process होगा उसको choose करना is also a very big headache for the systems. And the last method for recovery from deadlock is known as resource preemption. So you are familiar with this term, resource preemption. तो हमने डेडलॉक की एक नेसेसरी एंड सफिशिएंट कंडीशन पढ़ी थी नो प्रीएम्पशन की. कोई भी प्रोसेस जिसने रिसोर्सेज को होल्ड किया होगा वो तब तक उस रिसोर्स को रिलीज नहीं करेगा जब तक उसका टास्क कंप्लीट नहीं हो जाता, तो तभी हमारे सिस्टम में डेडलॉक होता है। तो अगर हमें रिकवरी करनी है तो हमें क्या करना पड़ेगा? टू एलिमिनेट द डेडलॉक्स यूजिंग रिसोर्स प्रीएम्पशन, we successively preempt some resources from the processes and give these resources to other processes until the deadlock cycle is broken. तो हम इस मेथड में रिसोर्स प्रीएम्पशन में क्या करेंगे, कुछ प्रोसेसेस से हम रिसोर्सेज को प्रीएम्प्ट करा के दूसरे प्रोसेसेस को दे देंगे ताकि वो अपना टास्क कंप्लीट कर लें। दैट मीन्स हम यहाँ पर डेडलॉक की जो नेसेसरी एंड सफिशिएंट कंडीशन थी नो प्रीएम्पशन वाली, उसको हम ब्रेक कर रहे हैं। और अगर हम उसको ब्रेक कर रहे हैं तो डेफिनेटली हम डेडलॉक को भी ब्रेक कर पाएंगे, बिकॉज उस केस में किसी ना किसी प्रोसेस को रिसोर्स मिलेगा, वो अपना टास्क कंप्लीट करके और बाकी सारे प्रोसेसेस को देगा। बट देयर आर सम इश्यूज इन दिस मेथड ऑल्सो। Very first issue is selecting a victim. So that means which resources and which processes are to be preempted. तो भाई वही सेम क्वेश्चन आ जाएगा कि कौन से रिसोर्सेज को हम प्रीएम्प्ट कराएं और कौन से प्रोसेसेस से प्रीएम्प्ट कराएं। हर कोई प्रोसेस चाहेगा कि पहले वो अपना टास्क कंप्लीट करे, तो फिर से वही बात आ जाएगी कि उसमें प्रायोरिटी मैटर करती है या क्या मैटर करता है कि किस प्रोसेस या रिसोर्स को हम सिलेक्ट करें प्रीएम्पशन के लिए। एंड प्रोसेस टर्मिनेशन की बात अगर हम करें तो बेसिकली जो हम प्रीएम्पशन करते हैं तो मिनिमाइजेशन ऑफ कॉस्ट का कंसेप्ट आता है। सो कॉस्ट फैक्टर्स के अंदर हमारे पास आ सकते हैं नंबर ऑफ रिसोर्सेज डेडलॉक प्रोसेस इज होल्डिंग एंड द अमाउंट ऑफ time the process has consumed so far. So there will be so many factors. एक प्रोसेस हो सकता है कि वो बिल्कुल टर्मिनेट होने वाला हो, खुद से उसकी ऑलमोस्ट सारी इंस्ट्रक्शंस एग्जीक्यूट हो गई हो, तो अगर हम उससे रिसोर्स को प्रीएम्प्ट करा रहे हैं तो वो और ज्यादा टाइम लेगा। सो there will be so many factors. So the very first issue is selecting a victim. तो कौन से रिसोर्सेज को चूज करें और कौन से प्रोसेस को चूज करें जिससे हम रिसोर्सेज को प्रीएम्प्ट कराने वाले हैं। Second issue is rollback. So rollback is another interesting concept. ये ट्रांजैक्शन में भी यूज होता है DBMS में, but I think आप लोगों ने अभी नहीं स्टडी किया है। So rollback simply means if we preempt any resource from a process, what should be done with that process. तो अगर हम किसी भी प्रोसेस से रिसोर्स को प्रीएम्प्ट करा लेते हैं तो उस प्रोसेस का क्या होगा? क्या वो प्रोसेस अपनी एग्जीक्यूशन बाद में वहीं से स्टार्ट करेगा जब उसको सारे रिसोर्सेज मिल जाएंगे, या फिर वो रोल बैक हो जाएगा? रोल बैक मींस रीस्टार्ट होगा, इट विल स्टार्ट एग्जीक्यूटिंग ऑल द इंस्ट्रक्शंस फ्रॉम द वेरी बिगिनिंग। सो दिस इज आल्सो अ वेरी great concern regarding this deadlock recovery concept. And the last and important issue is starvation. So ऐसा हो सकता है कि हम एक ही प्रोसेस को हमेशा बार बार चूज करें जिससे हम रिसोर्स को प्रीएम्प्ट कराते रहेंगे और उस प्रोसेस की कभी भी टर्न नहीं आएगी कि वो अपना टास्क एग्जीक्यूट करे. So this is how the issues are related with this concept of resource preemption. So majorly there are two important things in deadlock recovery. Either through process termination we can achieve deadlock recovery. In process termination either we can terminate all the processes, all the deadlock processes. Otherwise the second choice is that we can abort one process at a time, and after each termination we will check whether there is still a deadlock in the system or not. And the last method is through resource preemption. कुछ प्रोसेसेस से हम कुछ रिसोर्सेज को प्रीएम्प्ट करा के किन्हीं दूसरे प्रोसेसेस को दे दें ताकि वो अपना टास्क कंप्लीट कर सकें. सो दिस वे वी कैन आल्सो ब्रेक द डेडलॉक साइकिल. सो दिस इज ऑल अबाउट this entire chapter of deadlock, and till here the syllabus will be there in your T2 exam, and only one topic we have